Hello, Year 10. For our second lesson on bearings, we are going to move a little bit away from measuring angles with the protractor and start thinking about some of the angle rules that we already know that might help us solve some bearing problems. So, the objective for today is be able to use angle geometry to calculate bearings. So, we're going to think about some of the angle rules that we already know from lower school. So, when working with bearing diagrams, we can use rules such as angles at a point and angles on a line. So, we should know that the angles at a point add up to 360 degrees. And angles on a line add up to 180 degrees. So we might be using those angle rules in some questions in a moment. However, the angle rule that we will be using the most is to do with parallel lines. I've said since a lot of the locations involve north lines, a lot of these lines will be parallel. Any north line that you have drawn will be parallel with another north line. So we're going to have some alternate angles. We're going to have some allied angles. And we're also going to have some corresponding angles that we might be using. So just to remind you, if you can't remember your alternate angles, they are the ones that look like that, where the alternate angles are the same. We've got some allied angles. Allied angles, sometimes I think called supplementary angles as well, are these two angles here, and they add up to 180 degrees in parallel lines. And we've also got the corresponding angles, and your corresponding angles are those ones there, and they are equal. So let's look at some simple examples before we move into something a little bit more complicated. Each diagram shows the bearing of B from A. Calculate the bearing of A from B. So remember, a bearing is measured clockwise from the north. So this angle given here is the bearing of B from A. Technically, it would be 0.75. We want the angle going backwards. And again, that has to be measured clockwise from north, so it's all of that angle there. So how do you think we could work that out? Let's look at a couple of different ways you could do it. One way that you could do this is by extending this north line down. I already know that that is 180 degrees. And now by extending that north line, I've actually created an alternate angle. So this bit must be 75. So altogether, we've got an angle of 255 degrees. So that's one approach that you could use. Another approach that you could use is to think about allied angles, because this angle and this angle here make an allied shape. So these must add up to 180 degrees, which means this angle here must be 105. So the angle we want all the way around there is 360. Take away 105, which again gives me the answer of 255 degrees. Similarly, let's look at this second example. We've got an angle here of 122 degrees. I think I will use the same method as I've just explained. If I want the bearing of A from B, I need all of this angle round clockwise. These two angles are allied, so must add up to 180 degrees. So this must be 58 degrees. if I want to work out this bearing of A from B, I need to do 360 take away 58, which is 302 degrees. Now, there is a relationship between a bearing going one way and a bearing going the exact opposite way. And one of the easiest ways to explain this is using the compass. If I was walking out, say, on an angle of 30 degrees, or a bearing of 0, 30, the exact opposite would be 30 degrees more from 180, which would be 210 degrees. So the bearing one way is 0, 30. The opposite bearing the other way, it's sometimes called a back bearing, is 210 degrees. And these always have a difference of 180 degrees. So just a little shortcut that might save you some time. If you know the bearing one way, the bearing the opposite way is always a difference of 180 degrees. For our second example, I'm going to use it as an opportunity to see if we understand the language of a bearing from one place to another. And I'm actually going to see how many angles we can add to this diagram just with the information that I've been given. So it says, look at the diagram below. The bearing of B from A is 081. The bearing of C from B is 205. And angle BAC is 35 degrees. I wonder if you could label your diagram and get them in the right place. So here we go. B from A, well, that would be starting at A and walking out to B. And that is this angle here. So that is 81 degrees. I normally drop the zeros when I'm writing on a diagram. I just remember when I'm writing my final answer, if it is a bearing, it needs 3 digits. We're told the bearing of C from B. So C from B is walking from B to C. It's all of this angle here. And that's 205 degrees. And we're also told that angle BAC is 35 degrees. So where is angle BAC? It's not a bearing. B to A to C draws out that angle. So that angle is 35 degrees. But how many more angles can we now add to this diagram? And then we've eventually got to work out what is the bearing of C from A. So again, good chance to just pause the video here and just see how many angles you think you can add to this diagram. So here I go. Using allied angles, I know that this and this must add up to 180 degrees. So this angle here must be 99. I can work out this angle here, because the angles around point B must add up to 360. Well, 205 and 99 is 304, which must leave that as 56 degrees. Now then, I can work out this angle here because I've got another set of parallel lines with these two north lines. So the 81 and the 35 is allied with this angle here. So altogether, that adds up to 116. Just jot it down there. So that's all of that together, 116. So the 116 and this must add up to 180 degrees, making it 64. And remember, in an exam, there's always marks for writing angles on a diagram, even if you're not then sure what you need to do with the question. So always populate a diagram with as many angles as you think you can work out. There's a couple of different ways of working out this angle here. I think I'm just going to drop my south line in, because all of that would be 180 degrees to there, but all the way around is 205. So we've got a little bit of an extra angle of 25 degrees there. So this must be 25. And I could fill in some of these others, but I think I've probably done enough to get the idea. So, what is the bearing of C from A? Well, which angle is that we need? The bearing of C from A. Well, that's me starting at A and walking to C. So it is the 81 and the 35 all added together. We did that a moment ago. It was 116. So I've got some questions for you to try. It says work through the following questions, draw a diagram to go with each question. Again, if you want to print out the sheet and stick the diagrams in, I have no problem with that. Now, there are more questions here than I would expect you to get through. The questions do get more challenging as you go along. So it's up to you. If you want to skip a few questions out and challenge yourself, that is perfectly fine. Remember, you can always contact me in the Ask the Teacher channel if you have any questions.